All right. And when you do get the link, just let me know. Because I believe Xander from our team may or may not be able to make it. He had some travel issues pop up because he wanted to watch this afterwards.
Right. Sounds good.
All right. Looks like we have Adam. Thanks for joining, Adam. And how many people are in the room at Purdue?
Yeah, looks like we got about 15 people here.
Okay.
Uh-huh.
So if needed, Curtis, I won't be able to see everyone's screens there.
Right, definitely.
Oh yeah, we'll be able to.
Uh-huh. Yeah, we'll have our CAD training assistants here going around making sure we resolve any issues we need to.
Okay. Otherwise, someone could join this via Zoom, I suppose, and share their screen that way
Yeah, definitely.
if we needed to, or just someone's going to have to paint a picture for me.
Right. Yeah, if we run into more serious issues with someone, we can definitely set that up.
I'm not anticipating we're going to have any of those.
All right.
So shall we get started?
Yeah, absolutely.
All right. So if you want to hit record, that would be good.
Yep, we got that going.
All right. So everyone can see my main screen.
Yep, looks good.
All right. Excellent. So, all right. Looks like we have a picture happening now. Thanks for sharing. All right. Glad to see smiling faces. Glad to see everyone on campus. Awesome. We'd like to see everyone back in campus. Wonderful news. So again, thanks for joining us tonight. I know it's super late your time, so I do appreciate you guys taking time out of your busy Tuesday evening to learn about generative design. So I know everyone loves PowerPoints, so I'm going to go really quick. I just put a few slides here, and I really want to just position what generative design is. And again, we're going to spend the majority of our time inside of Fusion. So at this point, if you don't have Fusion up and running, now would be a good time to get that going. And I always think it's good to know who you're listening to. So hopefully, I know a lot of people that are already there, but there may be some new folks. So my name is Dan Banach. So I work in the education group here at Autodesk. And Fab Clayton and myself help support Purdue and some of the other top engineering schools here in the US. But my background, mechanical design engineering since the late 80s, 28 plus years now, training consulting both in academia and in the commercial space. And I'm also a published author. So I have 25 books that I've written on Autodesk mechanical CAD software. So that's a little bit about me, but we have a good supporting cast as well. And I'm not sure if Adriana was able to make it to the room or not. And I think Renee is online. Is that correct? So, okay, we'll take that as no, and I don't think Jeremy can make it. But anyway.
Wait, sorry, we were muted. They're both here.
Dan, they're actually here in person with us.
Oh, they are. They did make it. All right, perfect. All right, well, that'll be great. So Jeremy, Xander, and Adriana are on the tech side. So those three will be able to help support you guys on your adventures with Fusion 360. And Renee, who's listed down here on the bottom of this slide, she's helping us with marketing. So doing social media, and of course, getting people to attend this event as well, and others. All right. Anyone else want to say anything? Adriana, Xander, Jeremy, Renee? I guess we'll take that as a no. Okay. So again, if you don't have Fusion, it's also hopefully everyone has an account and is ready to go, but I always put this slide in here just in case. And I don't see anyone taking out their cameras to take pictures of that. So I think we're good. So those of you that aren't familiar with Fusion, so Fusion's a platform, And of course, with Fusion, it's cloud enabled. So all the files are saved in the cloud, and we're able to go from, basic design, engineering to manufacturing and everything in between. And the nice part, with being in the cloud, we get, collaboration that would be very difficult to do traditionally. But you're going to see here now with generative, we're also going to utilize the power of the cloud to do a lot of compute processing power. So everyone is going to get homework after today's sessions. So I'm not sure if you guys were aware of that, but you're going to get homework, and this is going to be the best homework you're ever going to get. You're going to click on one button, says generate, and then over the next few hours, you can watch how these outcomes are going to get built into Fusion 360. And of course, those are all being pushed out through the cloud. So what's generative? So generative design is all about design exploration. And as I had in the beginning slide, right, people are using generative design to make their designs lighter, reduce the mass, and also make components stronger. So a bunch of different case studies. If anyone wants, I can send you guys more information. Again, companies are using generative, for redesigns, brand new products. If designs are having failures, they're using generative design. So then I'll put my parent hat on here for a second. Generative design is also something that is looking really good on resumes. So this is new technology. So when you're starting to interview for internships and jobs after you graduate, bring up topics like generative design. Companies, they're hungry for people to come in with, new ideas, and generative design absolutely fits that. All right, so let's just do a little contrast and compare. So let's say today that you guys have been given a task to create a caster wheel frame, okay? Traditionally, you would come up with, maybe 2 or 3 different design scenarios, and then you would hopefully run a simulation. And then at the very end, maybe people start thinking about how will that be manufactured, right? And of course, if there are any issues, then you start the process over. Would everyone concur that's kind of what you do right now? You get a design problem, come up with 2 or 3 ideas, and then you start designing. Would everyone agree with that? So again, I've been doing this a long time and no one's ever disagreed with that, right? But again, that kind of gives a good baseline, right? So now with generative, what we're going to do is up at the very front, we're going to fully define the problem, and we're going to define it from a design perspective. We're going to put in the engineering. We're going to place in the So again, should it be 2 axes, 5 axes, added, find that problem. Then we're going to send that up to the cloud. And then that's where we're going to get multiple results back. So as you can see, up front, we're going to spend a little bit more time than you probably would normally to design that component, but you're going to see the results are going to be well worth doing that. All right, so from the manufacturing perspective, has everyone in here already taken some manufacturing classes, understands the difference between the 2 to 5 axes milling machining? Seeing a couple heads nod yes. Okay, so if you don't, when we get to that point, holler out and I can do a quick explanation. But again, with generative, when we get to the manufacturing side, this is all about design exploration. So show me different design scenarios. If I were to maybe, develop this through die cast or 3 axes or 5 axes, and the results, of course, are going to be very, very different. So again, design exploration based on manufacturing, because at the end of the day, we want to make sure that we give you a model, an outcome that is manufactured. That makes sense to everybody? All right. Now, what I'd like to do is just play this video, and this is going to give you a quick introduction to what we're going to do right after this, okay? So this is a Lightning Motorcycles. This company, they go after the world speed record. So of course, they want to reduce the mass all the time, right? So lighter, stronger definitely fits these guys. But here, again, we're defining what's referred to as preserves and obstacles. Again, geometry to keep and areas to stay away from. And then we define the engineering side, the stress calculations, how much stress and strain is going to be calculated. And then ultimately here, we're sending that up to the cloud. And then we're going to get, numerous outcomes back. And at the end of today's workshop, I'm going to show you guys some different tools that you can use to figure out of all those outcomes, which one best fits my requirements. We'll take a look at a nice chart that we can do. And then ultimately, when we're done with this course, we're going to export that model. And then you can, again, make changes to that model. So again, if you wanted to go back and add some additional fillets or holes, you could absolutely do that. And here it's just showing possibility what it would look like with some additive manufacturing, adding the supports. And of course, with Fusion, we can also create some toolpaths directly inside. So that is what we're gonna take the rest of the workshop through, going through all of those steps. Now, anyone in the room use ANSYS by chance? Any ANSYS folks? Doesn't look like it. So does everyone know what ANSYS is? So ANSYS is a company, they do simulation, high-end simulation. So Autodesk, we have a partnership with ANSYS. So if anyone ever asks you, can I bring that over to ANSYS? Any simulation study that we do, including generative, you can push over to ANSYS Mechanical and everything will come right across. So of course, obviously we can run those same simulations inside of Fusion, but some companies just want to validate. So that's what that is. Then lastly here, I want to talk a little bit about cloud credits. So when we send that study up to the cloud, a dialog box is going to pop up and it's going to ask you about cloud credits. So a cloud credit is another way basically of saying $1. So the good news is when you're logging in with your purdue.edu email, we are never taking your credit card. What you're seeing is what our commercial clients pay. You guys aren't having to submit your credit card. So again, it says 33 cloud credits. Just go ahead and click, go ahead and run that job. And Autodesk is picking that up. And just for reference, we are sending these jobs. We're utilizing the Amazon web servers. And of course, there's a cost directly to that. So, but your cost is 0. Now, let's get to the hands-on part. So I picked the little caster wheel frame for us to work through. And I printed one out. Hopefully you guys can see this. Printed a couple of these out. So it's a really small little caster wheel frame. But this geometry, again, is going to allow us to kind of walk through the process. And as we walk through this, again, I want to give you guys different tools in your tool belt to working with generative design. Okay. Everyone excited so far? So now inside of Fusion, the first thing we want to do is create a project, or if you already have a project created, that's wonderful. So again, log into Fusion if you haven't already done so. And then on the left-hand side, display the data panel. And if you already have a project created, wonderful. And if not, click on New Project, give it a name, enter. And I will again pause here for a second. And we do want this to be interactive, so feel free to ask questions as we go. Right, does everyone have a project created? Maybe just a show of hands, or someone can yell at me. Yes, we're good. You all good, everyone? Okay, so again, so now everyone has a project. So just one thing I want to point out. So there was a recent change done inside of Fusion for education accounts. So when you're creating a new project and you want to invite somebody in, you click on the People tab. Previously, you could just enter their email address. So now we have folder level projects. So now we can actually control roles at each folder. And we're going to do that out through Fusion Team. So right down in the bottom part here, just be aware of that. Again, it's not going to affect anything that we're doing today, but I just wanted you to be aware of that change. All right. So next, what we're going to do is we're going to open up this master frame. Again, this isn't a modeling course. And let me get over to Fusion as well. Let me close some of these other windows. All right, so let's go back to Fusion. And what we're going to do, go to the file dropdown, open, file, open. Then in the dialog box, scroll down to the bottom till you'll see samples. Everyone see the samples projects? Okay, then under samples, we're going to do workshops and events. So double click on workshops and events. Then in the middle section, education. So workshops, events, double click on education. We're almost there. Now after education, generative design. And then the file we're looking for is caster wheel assembly modeled. And go ahead and open up that file. And it should look something like so. Does everybody have the file? Okay, so now what we're really going to do, again, we're going to really work on this caster frame. And we're going to start pulling geometry out of this. So again, we're going to use terms preserves and obstacles, okay? Now, the first question that we usually get at this point is, okay, so this was modeled inside of Fusion, obviously, but could I use geometry from other CAD systems? And the answer is yes, absolutely, right? So when we're opening up files, and if I open from my computer here, you can see the long list of different file types that are supported to pretty much, any of the main CAD systems you can bring into Fusion, okay? Now, the other thing that we can do, let me just go back to the PowerPoint for a second, is, again, we want to pull out geometry with our preserves on the left-hand side and obstacles on the right-hand side. Right. So now, again, you can bring in that starter geometry, any CAD system, pretty much good to go. Or some people are asking, well, can I just model that geometry in 3D space? And the answer is absolutely. If you feel, confident enough that you can directly place in your preserved geometry in 3D space, maybe put in some work planes and do that, yeah, absolutely. But ultimately here, you can see we're really going after what we'll break it down to 4 cylinders for the preserved geometry, right? So now let's go ahead and do that. All right, so in the intro, so I again mentioned Fusion 360 is a platform. So how we get to all those different tool sets, if you go under the design dropdown, and click on generative design. So if everyone could go ahead and do that for me. And you'll notice now that the tool set has changed, okay? Now, whatever we do in this workspace will have 0 effect in our design, okay? So again, we're gonna start pulling this model apart. But again, that's going to have 0 effect on the actual design, okay? All right, so the first thing we want to do, the tool, the third one from the left at the top, go ahead and click on Edit Model. Then in your browser, go ahead and expand the model components And we're going to turn the visibility off of the wheel and the shaft. And here, let me start up a utility that I forgot to run here. So any of you that do any training, I use this little utility here called Zoom It. And get my fingers to work right. It allows me to do stuff like this. All right, so again, expand the model components and then go ahead and click on the eyeball symbol to the left of the wheel and the shaft. So we don't need to see those. We only want to work with the frame. Everybody good? All right, now I'm going to zoom up tight. So with Fusion, again, everyone hopefully has a wheel on your mouse. You can scroll in or out. Shift wheel, you'll be able to rotate your viewpoint, shift wheel. And you can also use the view cube. If you want to go back, you can click on the different vertices, different faces, orientate that. And you can also click and drag on the view cube, a little side tip. All right, now let's figure out how are we going to pull out our 2 cylinders for the 2 holes down here. Anyone in the room ever do surface modeling before? Any surface modelers? Anyone do any surface modeling? No? Couple? Okay. So after this, everyone's going to be able to say yes. So what we're actually going to do is I'm going to use a technique and we're going to basically create a duplicate of this hole and then give it a thickness. Okay. So again, it may sound a little strange. Why are we doing some surface modeling? But I think when we're done, you guys are going to see that was pretty easy, right? And again, remember, my goal with this workshop is to give you guys a whole bunch of different tools, you know, in your tool belt where you can go back and create these preserves and obstacle geometry. And again, let's go back at the very top. Go ahead and click on Edit Model Surface. So right up here, Edit Model Surface. We're going to click on that menu. And then from the Create menu, we're going to click on Offset. So Edit Model Surface, Create, Offset. So what, the 5th tool from the bottom? Offset. Then in the graphics window, go ahead and select the 2 circular faces that represent those bottom holes. And again, I want this to be an exact copy of that hole. So it's going to have an offset of 0. Go ahead and click OK. And you're probably saying, well, nothing really happened. Well, in your browser, you'll now notice we have a folder here called bodies. And again, let me zoom up on this. So if you expand the new bodies folder, you're going to see that we have 2 surfaces, 2 surface bodies. Now, our goal when working with generative design is we need to work with solid bodies. So how can we then take these 2 surfaces and convert those to solids? Again, from the Create menu at the very bottom, go ahead and click on Thicken. So again, Create menu, way down at the bottom, Thicken. And with my little utility, I get to do everything twice. So Thicken, and then select the 2 surfaces. And you see a little arrow. So you can click and drag on that. And what you can see here is which side is negative and which side is positive. So in this case, we're going to do negative 0.1875 or 3/16 of an inch. So negative 0.1875. Now, does everyone have 2 solid. And again, I had to do it twice again because of that little zoom it utility here. But now in our bodies folder, we have body 1, body 2, our two surfaces. Visibility is off. We don't need to see that. So that was automatically turned off. Now we have body 3 and 4. Is everybody there so far? Excellent. All right. So now, by the way, a tip, you don't necessarily have to do this, but if you would like, you can rename the bodies. So if you double click on there, you can, say like this is, front hole or something. Again, not a requirement, but again, if you're working, with, many different bodies, having body, 1 through 30, sometimes a little text cue might be a good thing. So then I'll call this other one the back hole, just so we know. Again, not a requirement, but a lot of people like to rename that, again, just for prosperity. All right, now, what I want to work on now is create that third body, and that's going to be the representative here of these two cylinders for my last part of my preserved geometry. Okay. So now the first thing we're going to do though, is we're going to go back to the edit model solid menu. So we're going to switch out of our surface modeling and go back to edit model solid. Now there's a whole bunch of different techniques, that we could do. By the way, we could just take this body right here and we could split it, right? We could just simply go back, split that body and then just basically copy this one body or move it into the bodies folder. So we could do that, or we can use a technique where we do a Boolean operation. And that's what I'd like to show you guys here. Let's do a Boolean operation. So from the create menu, click on cylinder. So create cylinder. Now, if you're brand new to Fusion and you're just wondering, what is Fusion wanting me to do? Just pause your cursor there for 1 second and you'll get a tooltip. So in this case, it wants to know what plane are we going to start on. So I'm going to click on that top horizontal planar face of the frame. Now, as you move your cursor, as soon as you get towards the center, a little circle will appear, basically showing you that you are now concentric. If you click on that point, it will be concentric. I'm going to move my cursor out and let's do something maybe like, 1.25 inches. And then left click. And we're going to pull this up. And the key here in the operation option in the dialog box, change this to new body. So again, this is the key right here, new body. And again, the body will have been created, which kind of makes sense, right? And again, if you want, you can rename that. But the question now is, how do I create this top geometry right here? All right, so we just created that top level cylinder, which encompasses it, but I really want to be left with this. Has anyone ever used the combine tool inside of Fusion before? It's awesome, right? So here's the deal. From the modify menu, what are we, 6 tools from the bottom? Combine, go ahead and click on the combine. So again, this combine, this is our Boolean operation. And we'll just walk through the prompts. So the target body, well, that's going to be the cylinder that we just created. Go ahead and click on this, that top cylinder. The tool body, what are we going to interact with? Well, that's going to be the frame. So just go ahead and click on the frame for the tool body. And then for the operation, right, our 3 different Boolean operations. So join, add them together, cut, remove, or intersect, keep what's common. And that is the one we want here. So keep what's common. And then in the dialog box, I'd also suggest we're going to check this option here called keep tools. And what keep tools is going to do, it's going to keep the frame. So if this was unchecked, the frame would disappear. I really don't want to do that. I want to keep that frame. So go ahead, click OK. Now what we can do, turn off the visibility of the caster frame. So again, in the browser, zoom up on this. I just clicked on the eye symbol to the left of caster frame, turn off the visibility of that. Now, does everyone's screen resemble mine? Are we happy? All right. Now, the good news is that is our preserved geometry. Those 3 pieces, my 3 bodies, that's what I need for my preserves. So now let's take a look at our obstacles. So again, obstacles, this is going to be the area which some people refer to as keep out. Do not add geometry here, right? And as we saw in the video, what generative design does is it's connecting the preserved geometries together. That makes sense to everybody? Kind of where we're going with this long term? All right, so what I'd like everyone to do is zoom up on those bottom 2 cylinders. And the first thing that I want to do is there's going to be a pin that's going to go through these 2 holes. So we give you a nice, easy tool to go back and work with like bolts, pins like this, cylindrical type of geometry. So from the Create menu, click on Connector Obstacle tool on the right side. And again, we're just going to follow the prompts. So the first option here is, where do I want to start? So here, I'm going to select on one of the outside circular faces that represents the hole. Now, if you shift wheel, rotate your viewpoint, go ahead and select on the opposite circular edge. And that defines, the inside where the axle is going to go through the 2 holes. That makes sense to everybody so far? All right, but now, so of course, there's going to be like a head on that pin so it doesn't slide through. Or again, if this was a socket head cap screw, we want to, make sure that we're not going to add geometry where that head's going to go. So then click on bolt head. And again, we can grab the arrows and we can define the geometry. And what's cool here, let me zoom up tight, show you guys a little technique here. So if you're grabbing on an arrow, click and drag. So that's basically active. And then I go back and select on another circular edge. It will snap to that point. So in this case, the head diameter was 0.75. I just basically determined that by snapping on that point. And then for the length, I'm going to put in 1/8 of an inch. So again, let me zoom up on this for everybody. So the head diameter is 3/4, length 1/8 of an inch. Now, as you zoom back, you'll notice that the head for that bolt is only on the one side. Well, but I want this to be a symmetric part. So then also suggest clicking on the option here called both sides. So click on both sides. And I think I'm going to get to do this whole thing again because it's zoom it. All right, let me do it again. Connector obstacle. And I'll just pick on that outside edge, bolt head. and then both sides. Does everyone's screen resemble mine? All right, now we're almost done with this, but now what we want to start doing now is just don't think about the hardware in its finished location. I want you to now start to think about assembly. I want to make sure that I have enough clearance to get a screwdriver or a wrench inside of here, if needed, right? So with that, we have the last option called tool clearance. So go ahead and click on tool clearance. And we can just throw in some basic dimensions. Let's just do 1, 1, 1 and do it on both sides. So that'll for sure will give me more than enough room. Again, from a generative design perspective, do not add geometry here. So for sure I can get a wrench in there, tighten it down if need be. Everyone happy? Go ahead and click OK. And again, if you want, you can rename that. So we could call it like obstacle. And we'll just call it like pin or something like that. Obstacle pin. Again, not a requirement to rename it. Sometimes it is helpful. Now, the next obstacle that I want to create is where the wheel is going to go. And again, a whole bunch of different things that we could do. Again, we could go back and we could create a sketch here. And then based off of that sketch, we could draw on a circle and extrude it. But in this case, we're working with cylinders. So I would suggest, let's just create another cylinder. So from the create menu, cylinder. Let the computer do the work for us, right? So what again, zoom in tight here, and I'm going to select on one of the inside planar faces of one of those first cylinders that we created. Again, that's going to be where the wheel could slide back and forth within. So I'm going to click on that face. I want it to be centered. Now, this is also a good time maybe to talk a little bit more about the view cube. So with the view cube, as I mentioned before, if you click on a planar face on the view cube, you can orientate your perspective. So in this case, now I'm looking directly on to the front view. So here I can see maybe like, like 3.5 inches might be good. So also, while you're doing the generative design, it's totally within your prerogative to make design changes, right? So if I wanted like those first cylinders, to be 1/4 inch thick instead of that 3/16 that we had, this would be your opportune time to make that change. But again, in this case, let's do 3.5, left click. And again, same deal. We can grab that arrow. I'm going to select on the opposite face on the inside to have it terminate. All right, so you guys have been using generative design now for a whole 30 minutes. What is the next thing that I need to do in the dialog box that is critically important? Anyone? I'm not sure if you guys have audio. It looks like you're on mute. So even if you're saying something, I can't hear you. All right, since you guys are on mute, I'll answer my own question. Remember, the key here is change the operation to new body, right? So cut would remove that material. That's going to do us no good whatsoever. So new body, go ahead, click OK. And again, if you want, you can rename that. So here, I'll just rename it to obstacle wheel. Everyone good so far? All right. For now, let's say that we are done. I believe that I have all of my bodies that I need to get going here. So let's finish edit model. So on the far right side of that top menu, go ahead and click on that icon. Now, one thing that I neglected to do, which we probably should have done, is save the file. So when we opened up that file, you'll notice it's a lock symbol, it's read only. So let's save our file. So from the file dropdown, click Save As. File dropdown, Save As. And again, just confirm where it's going to go. So the project that you created or you made active should be in here. And I'm just going to change this to caster frame gen design, something like that. And I'm also going to put in the date here just to keep my stuff straight. Purdue. All right, now what we're going to do for the rest of this workshop is basically just work our way left to right for the most part. So the next section here is the design space. So here we're going to define our preserves and our obstacles. Now, personal preference here, I like defining my obstacles first, and then we're going to turn the visibility of them off, and I'll explain why that is in a second. So from the design space, go ahead and click on that second tool called obstacle. Now, once you do that, in the dialog box, you'll see that it already has one body automatically selected. So remember the tool that we use to create, again, where that axle and pin's going to go through, was called connector obstacle. So we're making an assumption that that's going to be an obstacle. So in this case, our other geometry is going to be the wheel. Just go ahead and add the wheel to that selection set. And click OK. So now the wheel will go red. Okay. Now, in your browser, let me zoom up on this. You'll see that we do have the entry here for preserves and obstacles. Now, what I'm going to suggest is let's turn the visibility of the obstacles off. So just like we turned the visibility of those bodies off when we were working in that edit environment. So if we turn off obstacles, we're going to be left with our preserves. And here's why I suggest doing this. Because what we're going to do next is we're going to start adding the engineering side, the stress that will be applied to this caster. Now, stress can only be applied to our preserved geometry. We cannot apply stress and strain to an obstacle. Now, we can also do remote forces, by the way, that aren't contacting anything, but you cannot apply, stress strain to obstacle geometry. And the reason is, well, it doesn't exist, right? Remember, that's our negative. No geometry is going to be added there. So again, that's why I like doing the obstacles first and turning their visibility off. Then, now let's go ahead and click on Preserve Geometry. And you can go ahead and just select on our three, or if you like, you can just draw a box around the three. Go ahead, click OK. And they will now turn green. And again, in the browser, you can always come back and toggle the visibility, on and off of your preserves and obstacles as needed. Now, if anyone forgot to turn off other bodies that you're not working with, you can come back in here to unassigned. And then you can just simply turn off the visibility of unassigned bodies. Now, in this case, we already turned them off, so we're good to go. So we don't have to do that. All right, now, before we start diving into the engineering side, with our preserved geometry, I just want to talk a little bit about what's happening here. And for a second here, I'm going to turn the obstacles back on. So again, what generative design is going to do, can everyone see this all right if I make it closer? So what's again happening with generative is going to start connecting our geometries between the preserves, okay? Now, the term that I want to introduce here is called line of sight, okay? So if I go to the right side here, so let's say, kind of where my cursor is at, let's say I put in a plane that would go right above the wheel and below this, the top two cylinders. And that plane would basically prevent my preserved geometries from connecting. That would be problematic, right? So again, as you're creating your obstacle geometry, make sure that you have a line of sight. Is there a way for the green bodies to get reconnected? Does that make sense to everybody? Okay. So again, line of sight, again, we just need a way for this geometry to get connected. Now, there is something else that we can do, by the way, it's called a starting shape that will kind of tell generative design, how to start and connect that geometry. But again, good rule of thumb, make sure that you have a line of sight. All right. Now, let me turn that off. Let's go back to the PowerPoint. The next thing we're going to do is the engineering side. Has everyone taken a simulation class already? No? All right, so the question is, has anyone here ever broke anything before? Everyone has, right? So usually when we're breaking something, there's usually two causes, right? Either we overloaded it or potentially we used like a little plastic part as a hammer, right? Now, of course, in our case here, what we're concerned about is the engineering side, right? So when we apply stresses and strains, basically what we're going to try to tell Fusion is how is this part going to act when it's built and utilized out in the field, right? So I'm guessing some of you are also on some other project teams like SAE and Baja, stuff like that, right? So as you're making those parts, right, what kind of stresses are going to be applied to that? Now, the nice part with this caster frame, the reason I selected it, it's pretty easy to understand, right? I can see everyone's rolling around on their chairs. So your chairs have caster wheels, right? Everyone look below. It is probably some form of a caster wheel. Now, the one that I selected here, by the way, this is more of an industrial one, but same concept, okay? Now, let me introduce what's referred to as load cases. So you'll see here that I have 5 load cases selected. Now, these load cases, think of these as different points in time, okay? So the first load case is, it is just stationary. I have 100 pounds pressing down on the frame. That's it, right? Load case 2, and again, we're going to apply that 100 pounds to every load case. But in load case 2, I'm also going to be pushing a cart in one direction. Load case 3, I'm going to push in the opposite direction. And then I put a couple in here, maybe we're going to push it at an angle, right? When the caster wheel is going to start to rotate around. So again, just think of load cases as different points in time. Now, again, with that specific point in time, it can have multiple stresses being applied to it. That makes sense for the quick introduction. All right, so now I didn't want to do that. Sorry, let me go back to Fusion. So this, by the way, is probably the hardest part of generative design. And the reason I say it's probably the hardest part, because we're usually working on a brand new design and we probably don't have the engineering data, fully defined on how this is actually going to get loaded. Okay. So let's make some assumptions here. So first off, from the design conditions menu, go ahead and click on structural constraints. Now, I saw a bunch of hands go up that you guys haven't taken any sim classes or FEA classes yet. So when we're running simulations, we need to make an assumption, right? So with this caster frame, right? So of course we're going to have an axle that's going to go through here and it could spin, right? But think about if we were able to rotate around that pin and apply a force here, what would happen? It would rotate, not applying a whole lot of stress, right? So what we're going to do here, let me zoom up tight. For our structural constraints, I'm going to select the two inside circular faces of those two bottom cylinders, and I'm saying it cannot move. So now when I apply my force, the force is going to go down and not rotate the geometry. So fixed, two faces, go ahead, click OK. Everyone got that so far? All right, now let's apply a force. So again, from the design conditions, let's select the tool on the right-hand side, structural loads. So again, for this workshop, we're going to keep it pretty straightforward. We're going to work with a force, but also just be aware that you can apply pressures, moments, and varying loads. So now let me pan on down here. So the target is I'm going to select that top planar face of that middle cylinder, if you will. And I'm going to apply 100 pounds to that face. 100 pounds. Go ahead and click OK. Now, in that dialog box, by the way, you could change the unit, but there's a global setting that I just want you to be aware. So in the top of your browser units, if you click on that pencil icon, this is where you can set the unit. So if it comes in and it's in newtons and you really want it to be in pounds, I would suggest changing it here. Otherwise, you're going to have to override that unit for every single force that you're going to apply. All right, so now, just like we renamed our bodies, in your browser where it says load case 1, let's rename that. And I'm just going to call this maybe like load dash down. Because again, we're going to create a whole bunch of different load cases here. So again, I want to give myself just a little visual clue on what this means. Does everyone have the wonderful load case created? All right, now, if I go back to the PowerPoint deck, the next thing I want to do is create a second load case that's going to be pushing in, okay? However, I also want to keep maintaining that first force that we had with 100 pounds pushing down and the constraints. So what I don't want to do is have to recreate the wheel, so to speak. So here's the deal. Right click on load down and click on clone. So again, right click on load down and clone that load case. And again, I'm going to suggest that we rename that. So I'm going to call this down and in. Load down and in. Now, the most important thing to remember when you're working with multiple load cases, which one is active? So in this case, make sure that the load case that we just cloned is active. So here you can see I added the little radio button. I clicked inside there. So now my new load case is active. Now, if I, again, expand the loads, it has the force going down, which is good. And it also has the two fixed constraints. So that's good. Okay. Now, the only thing that I need to do, again, with that load case already active, is I'm going to come back up here again and click on structural loads. And now what I'm going to do is I'm going to select that long circular cylindrical face. I'm just going to rotate that. You can see the different arrows. I'm going to pull this out 90 degrees. And I'm going to apply 50 pounds of force to that face. And again, what I'm thinking here is, again, think about like pushing a cart, right? So we're going to push, we're going to have 50 pounds of force being pushed up against that circular face. How's everybody doing? You think you can do this on your own models, own designs? All right, good. All right, so now go ahead, click OK. So that load case is done. We're 2/5 of the way there. So now let's add some more tools to your tool belt here. Just like we were able to clone the original load case, I now want to clone the load case that has 2 forces to it. So again, right click, clone load case. And again, I like renaming it, totally up to you, but I'm going to change in to out. So it's load down and out. Anyone want to take a guess at what we're going to do next? Do I need to add another force? Yep, someone said it. We're going to edit it, right? So again, make that load force act or the load case active. So I'm going to make load down and out active, expand the loads. So force 4 is pushing down. So that one's good. Force 5 is the one that I would like to edit. So again, whenever we see the pencil icon, that's edit. So I'm going to edit force 5. And again, I'm simply going to click and drag on the arrow and rotate it. So it's going to go 270 degrees. And again, I'm going to keep that same 50 pounds of force. Right. So the cart, again, it's pushing, now it's maybe being pulled is what I'm thinking, right? The good news is, go ahead, click OK. We are then done with load case number 3. Now I'll give you guys an option here. Obviously, per the slide, we could clone one of these last 2 load cases and rotate them at an angle. So we could spend a few minutes doing that or skip that. Totally up to you guys.
Anyone?
We can do it.
Yeah.
You want to do it?
Mhm.
Okay. All right. So now the question is, which load case shall we copy? And again, it really doesn't matter if you want to do, load down and in or load down and out, totally up to you. Clone. And I'm just going to rename that. Maybe we'll just call it one at like 45 degrees. And when you're just editing a load case, by the way, you don't have to make it active if you're just editing one. So again, here I can come back and I'm going to change this one to 45 degrees. And again, feel free to, rotate your viewpoint. Sometimes it's easier if we look at this maybe from the top view. So here I can see where 45 degrees is coming in now. and then go ahead and click OK. And do one more clone. And by the way, the other option is you could take a load case. If I know I'm gonna, have like 3 of them based off of one, just clone, 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 and then come back and do your edits would be the other way to do this. And again, let's modify this one. I'm going to say this is going to be 135 degrees. Expand that, expand the loads. Now I'm going to edit force number 9. Now let's rotate this so it's at 135 degrees. Now, I suppose if we were really doing it, we should probably also, have the 2 angles also coming in from the top left and top right, but I think we're good with the load cases. Does everyone have 5 load cases created? Everyone good? All right, excellent. Now let's define success. So from the design criteria menu, go ahead and click on objectives. So how do we define success? So the deal here is, do you want to minimize the max or maximize the stiffness? Now, again, to start off, I normally just do minimize the mass with a safety factor. So let me just give a quick overview of safety factor. So let's say that we designed a table, and that table should hold 100 pounds just for simplicity's sake, right? 100 pounds on a table. Now, if I have a safety factor of 1, with 100 pounds or less, the table's fine. If I put 101 pounds on there, in theory, the table breaks. Okay. Now, with a safety factor of 2, even though I designed it for 100 pounds, it'll hold 200 pounds. 201, it breaks, right? Now, this is what I also refer to as a love-hate relationship. So the higher the safety factor, the higher the mass, right? You need to have more mass in your model. So usually what we want to do is have the smallest level of safety factor where it can match my requirements. In this case, I mean, this is a simple bracket here, right? So maybe like 1.5, if I go back here, like 1.5, 50% more, right? So in this case, we could load 150 on each of these little caster frames. So let's do that. 1.5. Now, also, let me dive a little bit deeper. So with generative design, what we're saying now is a safety factor of 1.5 or higher is okay. Safety factor of 1.5 or 1.49 or lower is failure. That makes sense to everybody? Right. So again, that's our minimum safety factor. Doesn't mean that it won't be higher, but success is not lower. All right, next, manufacturing. So this is what I was referring to in my introduction, okay? So again, we're just saying, what would it look like if we used these different types of manufacturing methods, okay? So up at the very top, by the way, is cost estimation. So we partnered with a company called A Priori, and what this company does is estimate how much items are going to cost when they're manufactured. So again, the higher the number that you have in here, the lower the cost will be. So again, the nice part here, especially when you guys start, doing interviews, hopefully you get a job working with generative. When I come back with a great design, if that design is, 10 times the cost of what it would cost to do, like a simple, design engineer would come up with a prismatic shape, the company is not going to go for that, right? So again, with this cost estimation, you're going to get a range. Then you can go back to your manager and say, I believe that the cost is going to be somewhere between, $30 and $50 to get this done. well, one, they're going to be really impressed that you knew that, right? But then you can back this up where this information is coming from. So again, that's where that production volume comes into. All right, next, manufacturing methods called unrestricted. So anyone in the room ever heard of unrestricted as a manufacturing method?
We have not.
That's good. Either have I, to be honest with you, because it doesn't exist. All right, so now you're wondering, well, if it doesn't exist, that's not a real manufacturing method. What is it, right? So unrestricted generative design is going to connect our preserved geometries together with no regard to manufacturing whatsoever. Right, so now you're saying, okay, that's great. Well, why, right? Think inspirational. Right. So we may get some designs come back with unrestricted that you've never thought about. Well, you know, if we put this angle over here, we put a strut over there, that could be really cool. Right. So we have companies that use generative design and they take the output, the outcomes, but then they go back and they parametrically will model that up as close as possible. So it's a little bit more prismatic, but again, it gives them great insights to what's possible. So that's what unrestricted is. And also with that said, by the way, you know, with today's additive manufacturing processes, most of those can be 3D printed. Do you guys have access to a metal printer, by the way, on campus?
Yeah, in Bechtel we do.
In Bechtel, they have a metal printer? Cool. So yeah, 3D metal printing is a game changer, right? And the nice part is every year that technology is getting better and better, which of course is additive. So here's the deal. Orientation. So what does that mean? So orientation, this is going to be how the component is going to be built on the build plate. So again, positive X, or I'm sorry, positive Z, negative Z, you know, X positive, X negative, Y plus, and Y negative. And it's going to matter, right? So in this case, whatever side that we say is going to come back down, usually generative design will go back and kind of make a platform for that to sit on. You're going to see that that face is going to be flatter. So in this case, I would just say, let's, you know, show me outcomes for all 6. I mean, it is hopefully a symmetric part. So we kind of maybe are doing a little redundancy with the X and Y. But let's see what happens. All right, so overhang angle, again, based on your supports. So that, again, is going to come from the machine. The minimum thickness, I'm going to change that to 3/16 of an inch. And you're probably wondering, well, why did I come up with that? So again, this is going to be personal preference. So I have 3/16 of an inch. That requirement was right down here that we did for the wheel thickness. And right up here, I believe this is 1/8 of an inch. So totally up to you. But I'm thinking, let's do minimum 3/16. Now, milling is the next one, right? So additive 3D printing. I'm going to minimize that for a second. Now, milling is subtractive. So here underneath that drop down, so 2.5, 3, and 5 axes. Should I do a quick overview explanation what those mean? All right. So again, if everyone kind of watches my fingers here. So with 2.5 axes, the mill will plunge down into our material and it cuts X, Y. Then it will plunge down to the next depth, cut X, Y. That's why they call that 2.5 axes. So it's cutting XY, plunge XY. With 3 axes, as the term kind of implies, the mill can move in X, Y, and Z simultaneous. So now just think about what does that mean cosmetically, right? So again, if you think about if the mill can only come down, cut, go down and cut, you're going to have sharp edges going all the way around. But now if the mill can go X, Y, and Z, we're going to get, you know, shapes that are going to be a lot smoother going around the corners. Okay. Then 5 axes. So with the 5 axes, of course, the mill can cut X, Y, Z, but usually then the material can rotate. They refer to it as the A and B axes. So it can rotate in 2 directions. So now, instead of having to do different setups and moving the stock with the 5 axes machine, you can get in and do some pretty complex cutting. The downside to that is some of the 5 axes machines are a little more expensive. Okay. So that's what those machines are. So let's start off with 3 axes. And now talk about tool direction. So what tool direction is, think of these as different setups. And basically what a setup is, when I put my stock material in the vise and I start cutting, that's one setup. If I have to take that stock material and then rotate it, that will be another setup. And rotate it again, another setup. Now, with each of those, by the way, this is where the manufacturing process is going to start to get more expensive, but might be a requirement, for this part. So again, we can say, include all 6 axes. And again, we might not need all 6 for programming this, but again, as we're just exploring it, show me what it looks like with all 6. Then the next option, minimum tool diameter. So let's put this in as 1/4 of an inch. So the deal here is the smaller the tool diameter, the smaller, the little connection points can get in between. So again, you can, come back and do different studies, place in, some different options for the tool diameter. But I found, working with Generative now for the last 3 years, the smaller that this is, the finer the little connecting pieces get in between here. So that's why I've been doing 1/4 as a minimum. And then tool shoulder length. So basically this is going to be the reach of the tool. So I'm going to change this to 2 inches. And the head diameter. So think of this basically as the chuck that's going to hold the tool. And I'm going to make that 1/2 of an inch. Let me zoom up on this so everyone can see what I did. So again, we're going to include all 6 axes, 1/4 for the minimum tool diameter, 2 inches for the shoulder length, and 1/2 inch for the head diameter. Everyone good with that? All right, so again, that's 3 axes. So let's come back up here and we're going to add one more. And I believe in the Bechtel, you guys have 5 axes machines.
Yes.
Which is way cool. So let's account for that, right? So let's go ahead and click on the plus symbol and let's change configuration number 2 to 5 axes. And again, I'm going to do the exact same thing that I did before. So 1/4 of an inch, 2 inches, and 1/2 inch. And let me show you guys something that's critically important. So all mistakes I make are for educational purposes only. But when you guys see text that is red, that means Fusion cannot calculate that. So in this case, it has no idea what IIN is. That's probably a good thing because either do I. But again, red text, try to avoid that. Is everyone good with 3 and 5 axes milling?
Yeah, I think so.
Okay, so the next option is 2 axes cutting. So 2 axes cutting requires a uniform thickness. So think water jet or a laser cut. Now, in this case, this is not a uniform thickness. So we're not going to use that option. And if we would do that, by the way, it'll tell us that's not a possible option with your current geometry. So die cast, is everyone familiar with die cast, right? We create the negative, mill in the negative, you pour in really hot material, it cools, you get your part. Now, the ejection direction. So again, as you go back, you create your mold how do you want to separate that mold is referred to as the different ejection directions. So now in this case, maybe we could do all 6, but again, looking at this for sure, we would definitely need a Y and a Z. And we'd probably also need something in the X direction to pull out of this middle. So again, I'm going to do all 3 to pull that out. So minimum draft angle 3, that's pretty common for mold design. Again, I'm going to change my minimum thickness down to 3/16 of an inch, and max we'll do 1/2 inch. And let me zoom up on this for everybody to see, and you can't see it with that. So die cast XYZ, and the only things that I changed here obviously is put in the XYZ, 3/16 and 1/2 inch. So now go ahead, click OK. Now the question for everyone in the room is, so after this, if you had to go back and start doing a generative design for your designs, does the manufacturing options make sense to everybody?
Yes.
Excellent. All right, you guys are doing great. All right, now the next thing we want to do is apply materials. So go ahead and click on materials. And for reference here, we can apply 7 materials in total. Okay. Now, what I'd like to do is place in all 7 materials, and then I can go through and work on each of these specific manufacturing methods and remove materials that I don't like. Again, personal preference. Some people will go back, for example, add additive and drop in materials just for additive and then just milling. So that would be the other option to do that, but I'm going to go back to all methods. Now we have different libraries. So the default here is the additive library. So we'll work off of that. So I'm going to click on the metal folder, and all you simply do is drag and drop. So I'm going to drop in the aluminum, and then I'm going to drop down, and let's maybe do like an Inconel. And again, as we're doing this, feel free to explore different materials.
Those materials apply for the whole part.
Did you repeat that question? I couldn't really hear it.
Yeah. Would that material, would those 2 materials be used in combination on the part, or is it gonna create one part for each material, like one kind of simulation?
Excellent question. Yeah, so we're going to get outcomes per material and then per manufacturing method. Excellent question.
Thanks, Dan.
All right, now, so you'll notice, of course, we're in our additive. We're missing a whole bunch of different materials, right? So what we want to do is click under the drop down for the libraries, and let's change it to the very top one, the Fusion 360 material library. This is the default one, by the way, and I get to do it all over again. This is the default one when you're adding materials at the design side on the design workspace. So Fusion 360 material library. And again, I'm just going to jump right down to metals, right? I'm assuming that this is going to be a different metal material. All right. You'll notice like under aluminum, see the little calculator symbol there? That means that a priori supports that material. Okay. So again, I'm just going to drag and drop aluminum, and you guys can go through this. I'm going to slide on down, maybe grab a steel. And show you guys one technique that I referenced before here. Let's. So for example, like I was talking about before, where you can drag and drop specific materials into specific operations. So let's say, for example, steel cast. Well, I know I'm not going to be using that for additive or milling. So now if I go back to die cast, I can simply drag steel cast into the die casting option. And that will not appear in other manufacturing methods. Right. So now let's say that I have all of the materials that I want to explore. Now it's going back into each one of these and removing the materials that don't make sense. So for example, under die cast, I'm going to remove the additive materials. But aluminum, yeah, let's explore. I mean, I can cast aluminum and I'm going to do steel cast. And I'll just work my way up. So milling, again, I'm going to remove, right click, delete the 3D printed materials. And otherwise we should be good there. So now I have aluminum and steel and milling. And then for additive, of course, I want to keep my additive material, but now I'm going to remove aluminum and steel. And then unrestricted, again, use all the materials, show me what's possible, right? So let me pause here for a second, let you guys go through the different manufacturing methods. Everyone good to go on the materials? All right, we're doing great. So now go ahead and close that. You can tell we're getting to the end here. So under the generate menu, go ahead and click on pre-check. And if you were watching that before, by the way, it was red before we applied materials because it couldn't do the generative design without materials, right? Again, remember, generative, we're fully defining the entirety of the problem up front. So under pre-check, all right, so I get 2 warnings. Basically, it's saying a couple of the materials that I've selected, I'm not going to get cost estimation on. That's okay, right? Now, if I did get a warning here about the milling, a common mistake that folks will make is, remember where it said the tool head diameter? That would be too large. So that could be problematic, right? So if it was like a 1/4 inch like we had, but we had like 2 inches for the head diameter, it's going to warn us, say that it's problematic. Then you would need to go back and change that. But in this case, I'm good with that warning. Now, the next one that I want you to do from the generate menu, come up here and click on the previewer, okay? Now, what's going to happen here, this is going to take about a minute or so. And what Fusion is taking a look at, it's taking a look at, again, my preserves and my obstacles. And again, it's going to show me where it possibly can be adding materials. So again, this is going to take about a minute, but this is going to be a minute well spent, right? Numerous times I've gone through and have done this. And then I realized that I forgot to add an obstacle. It'd be a bummer, right? If I, send this up to the cloud and the next morning I come back and it's, wrong, like this, for example, right? So again, what I'm looking for here, and I like using the view cube. So again, looking at this from the front view, am I okay getting the pin in there? That looks pretty good, right? So spin that around. So that's good. Do I have place for the wheel to go? So again, yep, that's looking good, right? My concern, of course, is right up here. So again, I'm going to have something that's going to be sitting down on that top cylinder. This is problematic. And I hope everyone would agree with that, right? But that's what I'm looking for when we run this previewer. So now, again, I'm going to stop the previewer because I have enough information here. All right, for the next section, my problem is now going to become your problem. So you guys have been using Generative for about an hour now. So you guys are experts. What do I need to do to fix this problem? Just how?
Obstacle around the top of that chapter.
Absolutely. Absolutely. Yep. So we need to add an obstacle. All right. First question, checkbox. Great job. How do I do that? The questions just got harder, huh?
Edit model.
Edit model. All right. Who said that? You get a gold star in the back of the room because that is 100% correct. Edit model. And of course, that's where we started, right? So that's where we created this geometry. And by the way, you don't have to do this, but just for reference, if you watch my screen, if I go back to the design workspace, you'll notice there are none of those bodies that we created exist here. They only exist in the generative environment. So now edit model. Now, let me show you guys another technique, okay? And I referenced this one before, but let me take a walk through this with you guys. So from the create menu, let's create a sketch, right? So all of you going through mechanical engineering, right? Parametric modelers, we create sketches, we draw, and we extrude, revolve. And I want to show that we can do the exact same thing here. So from the create menu, create sketch. And let's place it on that middle planar face on that cylinder. And then what I would suggest is let's draw a circle. And remember, when a circle appears, it's concentric. So I want it to be concentric. Let's make it 1 inch in diameter. Rotate your viewpoint. Remember, shift wheel, your orbit tools down at the very bottom of the screen. Everyone have the circle drawn. So finish the sketch. Or, by the way, you could have just pressed E on the shortcut key, by the way. But anyway, now that we finished the sketch from the create, because I want to go back to the create menu, extrude. Shortcut E. So I refer to this as a donut. So in this case, this is a pretty fancy donut, is we actually have 3 areas inside of our donut. And we're going to select the 2 outside areas, 2 outside profiles, not the inside, right? So we want to have a hole in our donut and we pull that up. And again, the most important part that we talked about before is
Body, new body.
absolutely. You guys are all going to graduate with A+. New body. And it kind of makes sense now, right? Hopefully, right? So again, remember, we're defining our preserves and our obstacles. Those are solids, right? And that's what a body is. So go ahead, click OK under new body, boom, OK. And again, you can rename it if you want. You don't have to. Then finish edit model. What do I do next?
To make that body obstacle.
Absolutely. Yep. So 2 ways to do that, by the way, right? The first thing that we did is we came back up through the design space and we clicked on obstacle. The other way, just to show you guys, in your browser, if you come back here and expand the obstacles, 1, it'll tell you how many bodies are in there. And again, we have our pencil icon. So either way, you're going to get to the exact same place, by the way. It doesn't matter. And of course, all we're going to do is select on that, go ahead, click OK. And it disappears. Why did it disappear? Yep, we have the visibility off, right? What do these blue arrows mean?
Forces of loads.
That's the load case, right? So remember, whatever load case you have active, that's what it's going to show there. So again, and you can turn the visibility of those on or off if they're in your way. But that's usually a question that we get is, again, what are those arrows? What do they mean again, right? I mean, we covered a lot, little over an hour. So, all right. So what I would suggest now is save your model. And remember with Fusion, every time we save, we get a version. So we can say, you know, added gen design study. Or finished study, it'd probably be better. All right. Go ahead, click OK. All right. So up front, I didn't mention that you guys are going to have homework, right? You guys are going to love this homework, though. If I was only your professors, right? Here's the deal. Ladies, gentlemen, from the Generate menu, go ahead and click on Generate. And this was the area that I was talking about with cloud credits. And so of course, I'm getting an error. You guys shouldn't be getting this error. Interesting. Not sure. I'm tied to the Autodesk account, which has unbelievable amount of cloud credits. But anyway, so, all right, I'm going to show you guys. I'm going to fix that in a second. But right now, you guys can go ahead and click on Generate. And let me show you something here. So preferences. There is a preference for these cloud credits, and it's possible that mine just got switched around. If I can find it. Cloud credits. It's not good. All right. So I'm not going to fix that problem because I only have 6 cloud credits left. All right. So I'll have to come back and rerun this later. That's a little embarrassing. But the good news is, so you guys are going to start to see these outcomes being generated. Okay. Does everyone know who Julia Childs is? Everyone heard of the movie before, seen her? So she's a famous chef, right? And what she would do is she would, you know, put together her recipe, then she would put it in the oven, and then miraculously she would pull one out of the oven. This is my Julia Childs imitation right here. So here's the deal. Let me just finish this. So again, what's going to be happening here over the next 2-3 hours, you're going to start to see these outcomes being created, right? And obviously we're just starting with, you know, a blob of material, and it's going to start removing mass. Okay. So here's the deal, right? So now, as soon as that study was sent up to the cloud, you can continue working with Fusion. You can close Fusion. And then the next time you come in, open up the file, then click on Explore. And it will bring down from the cloud these studies. So that's wonderful, right? So don't worry about, you know, what happens if I close Fusion? Nothing, right? This is all sent up to the cloud. It's all going to be fine. All right, so now how much time do I have? All right. So here's the deal. On the left-hand side, this is where you can start to specify and show me maybe under the manufacturing. So show me additive. So I'll isolate on additive. And I'm just going to pick on 3 of these. And down at the bottom, I want to do a comparison view. So obviously you guys can't do this yet, but in about 3 hours, you will be able to. So remember when we did additive and we talked about the setups with the Z, Y, and X? You'll notice when I clicked on that top left frame, on the right-hand side here, it's saying orientation, Z plus, additive. The top right, additive, Y plus. Bottom left, Y negative. Now, as you rotate these around and you zoom up on that, you can see that all of the views are synced. But again, based on our geometry here, so you can see like one side is flatter. Again, that's going to be, where the build is going to be on the platinum, right? So anyways, I just wanted you to be aware, pay attention to whichever one of these is active. You're going to get that information on the right-hand side. So now just for reference here, I'm just going to close off 2 of those here, easier to see. Now, there's a whole bunch of things that are happening on the screen here. So across the very top, how do you want to look at this? But you can now also turn on the stress view. So again, remind me where the stress strain's being applied. Let's turn that back off. Remind me where the preserved geometries were. So again, this is a really good reminder, right? So remember our preserves, that's what's being kept. And you can see now where generative is connecting the dots. Remind me where the obstacles are. Yep, so generative is doing exactly what we asked. It's not adding geometry there, so that's good. And of course, as you guys are going through, you can add tags to these labels. And then ultimately, let's say that you are done. You figure out, I want this outcome. I want to use it in my design. We have 2 options up here, design from outcome and mesh design. Now, I strongly suggest use design from outcome. Design from outcome will give you the recipe. And I'll show you what that means in a second. But basically what you're going to be able to do is go back and make changes to the model. If you do a mesh, think like an STL file. This will be triangles. Not a whole lot you're going to really be able to do with that. So of course we can always create an STL file, a mesh file, from a parametric design, but harder to go the other way around. Fusion can do it, by the way. But so again, as you're taking your outcomes, do design from outcome. Now, down at the bottom of the screen, you'll see that in this case, it took 35 outcomes. Now, I won't painstakingly take you guys through all 35, but what you can do is you can start clicking through, and this is, by the way, what you're going to start seeing on your screen. So let me bounce this down a little bit. So right now we can see where the mass is 0.229. So safety factor 4.1. Let's just go up to 20. So obviously we can see we have a huge reduction in mass and the safety factor is going down. So now from design 20 to 35, generative is, running the algorithms and trying to make the design better. Now, the reason I wanted to show you these outcomes, you can make any one of these outcomes active like I have here, and you can create an outcome from any one of these designs. It doesn't have to be the very last one. Okay, so definitely explore that. So that's that. And again, you guys can isolate, you can see what the 3 axes is, the 5 axes, die cast. And by the way, you can also, while you're just previewing these, scroll through that, show you how it's building up, which is pretty cool. Impress all your friends. So does that make sense on the left-hand side? Again, what's important to you? will display over on the main window, okay? Across the very top, you can look at this from a properties view. Engineering students love creating scatter plots, right? Not so much, but you'll like this though, right? Because we're going to create it for you. And here you can designate, what do you want for the vertical column and the horizontal, right? So again, you can determine that. Now, when you select on any one of these, of course, the dots represent our designs. So as you go back and you select on any one of these, it will appear here on the right-hand side. Then we have a table view. So this will be a little light reading for you, right? Now, of course, this is a lot of data. Now, one thing that we just recently added to Generative is export to CSV. So if you really wanted to analyze this data, I would output this to an Excel file and figure out what you want to do there. Does that make sense to everybody? Right? So again, use these different tools how you see fit. Now, as you're going through these different generative outcomes, don't be too surprised if you get the very first, design outcomes back. You say, well, I don't like them, right? I'm missing something. Maybe I don't have enough force, maybe there's, really weak little sections in the middle. This is, again, where you can go back and make changes, right? Go back and, adjust the forces, add additional forces, change the different manufacturing methods, rerun it. So we have found that people usually will do 3 different design outcomes, send up 3 different studies till you get your results, okay? Now, one thing I didn't talk about, but you can also use that starting shape that I mentioned before. So sometimes, you may like one of these outcomes right here, but you just want to fine tune that. You can export this model and use that as a starting shape. It's kind of cool. All right, so now last thing I want to show you. So let's say that I exported that model. Let me open up. This one was for 3-axis milling. So I mentioned with the design outcome, we give you the recipe. So remember with Fusion down in our timeline, that's where all the features are, right? And this is what I was referring to as the recipe. So if I grab that part marker and just move it, should look familiar, right? Preserves, obstacles. And this second or the third section here is what Generative added together. And then we're doing a couple different Boolean operations to get a final result. Now, let's say that I want to make some changes to this. Maybe I want to cylindrify a section here or this section. So if I come back down here and I double click or right click and edit that form, anyone on the call or in the room do any form modeling with Fusion T-splines? Couple of yeses.
Yes.
Right. So again, tons of tools here. So example, under the modify menu, if I had this area here or this area here that I wanted to fill back in, I would use the fill hole. But the tool that I wanted to show off here is cylindrify. All right, so everyone's second piece of homework in a conversation tonight, people outside of this room, use cylindrify in a sentence. There you guys go. All right. You know that you have issues when you're using cylindrify in a sentence. Anyway, so let's come back here and I'm just going to grab these and go ahead, click OK. And of course, as you would imagine, it's going to make it more cylindrical in shape. So again, really great tools. Go back and make modifications as needed. Right? You can also obviously just grab some faces. Here, let's grab 2 of these. And if I right click, edit form, move this out of the way. If no one's ever seen T-splines, think of T-splines being able to model with clay, but with no mess, right? Again, think about just being able to drag that in or out or scale it. How cool is that, right? So again, you're in complete control here, right? You're co-designing with the cloud. So if there's something that you don't like in here, you can make edits to that. And just a couple last things just to finish this section up. You can also come back here and you could add fillets, for example, right? If I wanted to go back and fillet that back off, we can add those features or add whole features, other extrudes, revolves. And then when you're done, go back to the simulation. So remember all the different load cases that we created? Well, we're going to pick up on that, right? So right here it's saying, well, do you want to reuse all of those? Yes, I do. And it's going to bring back all of those load cases for me. I don't have to go back and recreate those. So now all I simply need to do is come back up here and solve this. And again, the nice part is I can send this up to the cloud as well. Of course, if I had enough cloud credits, I could send this up to the cloud. Then again, just finishing that ANSYS thought that I had before. So again, if anyone does have ANSYS or wants to validate this, you would simply just click on the ANSYS and it's going to send this to ANSYS Mechanical directly if you have ANSYS Mechanical installed. If you don't, like I do, I don't have it installed, I'm going to create this SDZ file, which is going to contain everything, open it up in ANSYS Mechanical and run it. Simple as that. And then last part here, remember, just like I showed you guys in the video, right? So what I did with this one, just created just a real quick, simple setup here for, and I believe I just did a roughing operation, adaptive. How many people are doing manufacturing on the ASME? You guys have a bunch of folks doing that? Let me simulate this. Because the nice part is, you know, the Bechtel, they're pretty much using Fusion across the board. So what you guys are going to be able to do here, we'll go directly over to the Bechtel. So, and that is what I wanted to show you guys with the workshop. So we'll open it up for questions, thoughts, feedback.
So yeah, I know you were talking about, you know, the different iterations for each outcome and saying that you can choose, you know, not the last one. So I guess my question is, when it's generating the iterations, is the last one usually, I guess, like prime, like or most efficient or most meeting the requirements? Or is it like the last 5 or something?
Yeah, that's a good question. So usually the last iteration is the best one, right? It's one that's going to come closest to our criteria that we've set, usually, right? But again, visually, is that the one that you want? That's up to you.
Can you put a limit on how many iterations like you can run, or will it just run until, I guess, it meets the repair requirements?
Yeah, another really good question. So you and I cannot put a cap on the number of iterations to go through. Now, programmatically, I believe that they do have a cap on that. So if you run across something, you know, it's looking like it's like 80% done, right? You can, again, take that, use that as a starting shape and start there, right? And then it should get a lot further. I knew that kind of had one little thing that I wanted to show you guys. So in the top right corner of your screen, if you click under your profile picture, preferences, what I wanted to show you guys here is some tools that we're working on. So if you looked really close at the model, this is a symmetric part, right? However, you'll notice that I didn't have the option to define planes of symmetry. But I wanted to show you guys some things that we're working on. So under preferences, down to the lower left-hand corner, preview features. And here, just show me generative design. So die casting, I believe, is on for everybody, but we have the experimental solver. And with the experimental solver, we're working on algorithms for doing symmetric parts. So again, if you want to kind of see where we're going, take a look at the experimental solver. Now, with that said, is everyone aware how fast Fusion is updating? So we're on a 6 to 8 week release cycle. So the reason I mentioned that, so for example, you'll notice if something wasn't here today, but let's say that it appears, let's say maybe like March 28th around 9:30 Eastern.
Just by chance.
Just by chance. Yeah, so anyway, so tongue in cheek there, but next Monday on the 28th, we are releasing the next update to Fusion. And there's going to be some really cool things happening with generative design. So watch for that. So again, it'll be the evening on Monday. But Fusion, we're on a really fast release cycle, every 6 to 8 weeks approximately. So we're working on lots of things, and these preview features here give you a pretty good glimpse on what we're working on. So just wanted to point that back out. So again, feel free to play around with that solver. And Fluid Path is pretty cool too. If you guys ever need to go back and show how we can go from point A to point B. Another kind of cool piece of technology we're working on. All right. 9 minutes.
Yeah, that's perfect.
Yeah.
I have a question.
Oh, we got one more question. Yeah.
Sure.
Any other criteria you maximize it for other than just stiffness or mass reduction?
Yeah, can someone repeat the question? I couldn't hear it.
Yeah, just come right up here.
Does Fusion have any other criteria that you can specify other than just mass reduction or maximizing the stiffness of the part?
Yep. So with well, you guys are bringing your A game for questions. When you turn on the experimental solver, why don't I just do that? I think I unchecked it. Turn on the experimental solver. Under objectives, you'll notice we now have modal frequency, displacement, buckling. Again, kind of give you a glimpse on what we're working on. Did that answer the question?
Yeah.
So, yeah, so generative design has grown immensely over the last 3 years. And there's lots that we want to add to it, no doubt about that. So, all right, anybody else? Any other questions?
I think we're all good, Dan. Thank you so much for taking the time to present, show us all the new stuff Autodesk is coming out with, generative design and whatnot.
Absolutely. Well, and of course, with that, one more thing,
Yes.
right? So of course, if you guys, everyone, I'm sure are now experts with generative. However, if you want to just kind of also do a little recap, under the question mark, learning documentation, self-paced learning is a great place to find some tutorials here. And let me bring it over to the other screen. So these are tutorials that I'll usually direct people to that are just getting started with a section inside of Fusion. So for example, here, generative design. So this one is based on 4 videos. This one's 3. Click the arrow to the right, and you'll see some additional tutorials that you can run through. So that was the other thing that I wanted to do. And there's an awesome Fusion 360 YouTube channel that has tons of great videos on it as well. So, All right, so that is what I wanted to present to you guys. So hopefully this met your expectations.
Yeah, for sure. This was great.
Right. So again, I appreciate you guys taking time out of your busy school schedules to spend a whole evening with me. But if you can send me the link to the video,
Yes, definitely.
that would be great. So,
We'll send that whenever it's uploaded.
right. And then remember, so Jeremy